Hello, everyone. Good morning. So thank you for coming. And uh, it's going to be your first Q&A to cover lecture week number 1. We didn't cover, well, we covered quite a bit, to brush up your memory about discrete math. I think week number 2 will be heavier, but I'll give you a little bit heads up about that's something you definitely want to pay attention to. And we're going to run through the Google Doc questions I saw, and then you can feel free to ask me questions live as well. I can definitely handle them. And that'll be it for today. And in later sessions, once we cover more materials, I'll try to bring you guys maybe some extra problems to really solve. So that can definitely reinforce your understanding. So in some way, there's a benefits to really, when you attend the live session, don't really try to think you're just gonna watch the recording later. I'm pretty sure you guys got another hundreds of hours of video to watch for other courses in total. So you don't want to add just this one to the list, okay? And one of you guys actually asked me a very good question about returning in person, right? To be honest with you, I haven't got any new information from the school, the university. So at the moment, the only thing I can say is until January 31st, right? Everything's going to be online, okay? And starting from February, we simply don't know. However, for you guys, you should know, you should have got an email from the universities. So something about the York Virtual Town Hall, right? I'm pretty sure you got some email about it. If you go to that email there's a Zoom link. I believe tomorrow, 1:30, tomorrow, Friday, January 21st, I believe they will talk about the ongoing plan for the winter. Maybe by then, maybe between now and tomorrow, 1:30, they will actually announce something official to say what we're going to do beyond January 31st. I would say for now, you don't need to worry. Tentatively, right? It's not exactly for sure. Of course, I need to confirm everything once I got the instructions, from the university. I can only follow, right? So I would say what's guaranteed not to really change will be as follows. For your lectures and also for your Q&A, right? For these two, these are the main study materials for you, for your test and for your exam. And for all these kind of stuff, even if we return back in person, even if we do, we don't know yet, but even if we do, they will still be made available remotely for sure. I'm not gonna change that. Okay, I want to make some flexibility for you guys available. However, I can tell you that, of course, the catch is if you actually got the lectures recorded, pre-recorded, you have to make sure you actually study them steadily. You don't want to accumulate like 20 hours of lectures before the test occur. That's not something you want to do, right? I cannot really force you to really watch every day, but please play your time, all right? So all your Q&A, all your lectures will definitely remain available remotely. We might decide, even if we decide to maybe run a Q&A, maybe in person, I'm not too sure about it, but I need to decide later. Even if I do that, I'll make sure I record it. I'll always make it available to you online. So if you don't really feel the need or you don't really feel safe for whatever reason, you definitely don't need to come to campus, right? However, hypothetically, if we return back to campus in person, hypothetically, right? If that was the case, in that way, remember the stuff that we have. Number one, these are the possible changes which I need to confirm. Number one, for the scheduled labs, I consulted with 3 of our TAs. One of them actually expressed no preference as to whether they want to hold it in person or maybe remote. Because they are also students, they are coming to the campus anyway. So possibly we get maybe at least one session will be held in person, and for the other two, they will be held remotely. I don't know which one just yet, right? But I think other 2 TAs, they actually feel more comfortable if they can keep over the Zoom, right? That's something I can confirm. But for the scheduled lab, if you really want to see, want to interact with the TA face to face, there's a possibility. But I need to double check with the TA to see if they still feel comfortable. Let's say when we really have to return, hypothetically. Another thing that might happen is about the office hour. I think for the office hour, I might consider, for example, to currently my office hours on Monday, Tuesday, and Thursday. I might decide to turn maybe one day out of it, maybe to be in person. So if you really want to talk to me, you can definitely come to campus and then speak to me. If you maybe in that way, that can help you maybe getting more engaged into the course. Okay, that's something I also need to confirm. I'm just saying tentatively, right? Could be larger than one in person. Okay. Okay, another thing that's definitely also very relevant is about the tests and exam. Okay, let me talk about them separately. And for the tests, this one I cannot tell you anything now, but of course at the moment, at least for your written test number 1, that's actually going to occur on February 1st. That one for sure is going to be online. That one is actually way too close, so we don't want to change anything. But maybe starting from your written test, I believe we got 4 in total, right? If I remember correctly. So we actually got 2, 3, and 4, and also your programming test. Those are the ones I need to confirm whether we're gonna hold it in person during the lecture time or we're gonna do it remotely. So for that one, let me confirm with you later if we really have to make that decision. Okay. Of course, if they simply say we're gonna extend online until the end of the semester, everything will be online for sure, right? The final thing is about exam. Okay. What I can tell you is I was asked by the department yesterday about how we want to run the exam. It seems like they only gave me the option for in-person exam from the email I received yesterday. However, they said if I really want the exam to be online, I can request, right? So I simply replied back to the department asking if I can have the flexibility to say maybe I will still apply the in-person exam just to make sure we got the lecture hall or whatever that's reserved. But if I really decide to hold it online for everybody's best interest or for mine as well, in that case, I can also change, right? So I think for exam, still, there is a possibility that we may have to run in-person exam like everybody else. There is possible. But we simply don't know. Yeah, sorry about so much uncertainty, but I know I don't really know much more than you do, right? We still have to wait until this particular deadline to see what's going to happen, right? So guys, do you have any other concern about this subject over here, about in-person? Any other concern? Go ahead.
Sorry. The only concern that I have is if you get sick and stuff and you have to miss the 5 days, or I don't know how the regulations are for other people. I think that's the only thing it's my concern. It's not about going in person and stuff like that and writing the test. It's just about getting sick and missing your in-person and your tests and all your courses. I think that's what probably stresses me out the most.
Sure.
And it's just I'm just wondering what would happen in situations like that and stuff like that.
Sure. It's a fair question here. I cannot really speak for my other fellow instructor. They may have different policy, but at least I can, let's say for this course over here. Let's say if somehow unfortunately really got sick at some point in the before the end of the term, I think for the lecture and Q&A, for that one, you definitely wouldn't get disadvantaged. You definitely got all the recording available. That one's okay, right?
I appreciate you doing that.
Yeah, no problem. To be honest with you guys, you didn't really take any courses with me before. I did it before the pandemic already. So anyway.
Yeah, I had you in first year Java in person.
Oh, when was it?
Yeah. Fall 2018. No, winter 2019. Yeah.
Oh, that's I see. That's must be 1021.
Yes, it was 1021 exactly.
Oh, wow, that's a long time ago.
It's a long time ago. But then this is the second class that I'm having.
Okay, awesome, awesome, good, no problem. And let's now talk about the tests over here. Since I still need to confirm with you guys whether we're still talking about hypothetical scenario where it's in person. If I decided that I'm gonna run these tests in person, and in case you got sick, of course, don't come to campus, right? I think that would be the best for both you and for us.
Everyone else.
And in that case, I think the way I think either our department chair or some higher up, they advise we simply treat cases like when students couldn't really come to test because they are sick, like a normal situation. In which case, maybe I can just provide with me, if you can provide with me maybe some basic documentation, we can speak about exactly how we can accommodate. But I think I wouldn't give you any penalty if you missed the test because you were sick, right? Maybe either, hopefully you wouldn't contract COVID, but maybe just a normal flu. In that case, once we get some necessary documentation from you as a formality, in that case, either we can. Normally, I wouldn't give any makeup test because since everybody has taken that already, either we can decide to shift the weights to other tests, or we can shift that to the exam. Of course, the exam is pretty heavy already, but that's something I'm
Yeah.
flexible to discuss. But at least you wouldn't get penalty just because you missed the test. That's what I can say.
Okay. Yeah, sounds good. Because I know like when my cousin like got COVID, she could not like get out of bed to even
I
do
know.
her online like work. She was really not feeling well. So
Yes.
it's just like with stuff like that and like not being able to feel well and like being caught up behind, that's
Yeah.
the only like stress. But you have your lectures and Q&A like
Mhm.
online, whereas like some other like professors and stuff like aren't doing that. So that's why it's like I'm sure like a lot of students will appreciate
Yeah,
that.
no problem. Guys, again, I think for myself, I'm more than happy to do so. And then I think if you got such concern, maybe also maybe speak to your other professor as well to see how they might deal with. But I think we will be, there is an EECS departmental meeting tomorrow. I believe our chairman will give maybe some general guidance to see. But I think, yeah, that's basically at least what I would do. And for this part here, I will just need to confirm once we know about more definite answer. But I think you guys are encouraged to attend the virtual town hall held by the university tomorrow. It'll be 1:30, right? You can definitely check your email. I'm pretty sure you got one email from before. Yeah, good. Harsha,
Okay, yeah.
question.
Thank you.
You're welcome. Harsha, go ahead.
So like if we like let's say somebody at our house gets COVID, we get COVID, something like
Mhm.
that. We're not sick. We still
Oh, I see
can do
what
an
you mean.
online test. We still can do an online test, but
Yeah.
it's the law to not break the quarantine. So in that case, we're essentially supposed to follow the law, of course. You
Yes.
shouldn't spread anything, even if you're not sick. But
Yeah.
then isn't the student suffering a consequence by having their weight shifted? And arguably, like weight shifting is never a good thing for any class, right? You want it to be more distributed. So then isn't that just a disadvantage in itself? Would there
Uh,
be an online option for that person? Because I personally don't think that, it would be a 2 week quarantine. And if you have one test missed, you're likely missing a bunch of other tests in that 2 week
I
because
see what
these
you mean.
terms are in waves. So that's probably, that's probably the end of your semester, in my opinion, for an average student.
Yeah.
I'm pretty average. I don't think I would be able to come back from that.
Mhm.
Uh, so what do we do for that, right? Like that
Yeah,
doesn't seem
I do
that
hear
doesn't
your
seem like
points.
a good learning outcome.
I do hear your points. You're basically saying that if I decided, for example, to run the test maybe in person, in which case, let's say you don't have any symptoms, but in that case, of course, you gotta get yourself isolated. In that case, shifting weights may not be the best for. Well, I can understand what you mean because you might put too much weights on the either exam or well, exam is pretty heavy already, but or on the test. What you're suggesting is it possible to say maybe set up some online exam, maybe at the same time as everybody else is taking the test. That's what you're suggesting, right?
Or makeup.
Makeup. Yeah, Harsha, how about this? Your notes or your opinion are well noted. I will definitely consider for sure. I can see your point. I can see where you're coming from. Either a makeup or, but of course, the makeup gotta be online anyway, right? Because I don't usually want to wait for that long. Like if we're waiting for two
Right.
weeks before you take the makeup test in person. We that's under many assumption. We're assuming that if these tests are going to be run in person, and then in that case, of course, if you actually need to isolate yourself, in that case, we may need to provide some option for you rather than shifting the weights. It's well heard. Let me consider them.
Okay. And also another thing you said about the documentation. I
Yes.
think the Petitions and Appeals Committee, they made a rule very recently last year. I was actually part of helping make that rule with some of the professors. They the rule would say that for a semester test, if
Mhm.
you're sick and you need to miss it, you actually don't have to provide any documentation or doctor's notes. I don't know if that's gone through or not. but it's
That
only
one
for the
there,
final exam where you need
let me
documentation.
also consult with my maybe the leadership team in the department to make sure if regulations say I cannot really request anything for you, then I cannot, right? But maybe things either don't go through or changed. Let me consult with them to see what happened, right? Okay, Harsha, does that kind of answer your question?
Yeah, that's everything.
Okay, good. Guys, any more concern, any questions? It's good to speak up right now if you got any more questions. All right. Okay, good. Just stay tuned, and then you're welcome to really you're encouraged by the school to attend the virtual town hall tomorrow to listen to the latest updates. That's maybe most likely what I will do tomorrow to also get myself prepared. There's another thing which I heard. I'm not too sure if that's really true. If we really want to go back in person, maybe some people say maybe the earliest timing will be after the reading week. That's another saying. Not too sure if that's really true. Again, it's only rumor. Okay. All right. So hearing none, seeing none on the chat, let's now talk about you guys' question quickly. Okay. All right. Let's now go on over here. Oh, let me just say some very quick announcement just to make sure you guys are up to speed, right, for everything. Okay. And for Schedule Lab, again, it's optional. It's completely remote for the moment. Optional. It's really for you to talk about maybe either your lecture materials. If you got any new question that's beyond the Q&A, you can feel free, or you can just reach out to me always by email or office hour. But if you want to feel more comfortable speaking to a TA, no problem. Just go there. I think all of them are pretty good. Yeah, they actually completed the same course before, and they knew the material, so you can definitely consult with them. That's no problem. And we didn't have quite many show up, but again, it's the time is really made for you. Well, I will try to watch out. I'll try to monitor how the attendance has been like. If there's really a particular session, for example, like a Wednesday morning, if really nobody can really make it, maybe it's just too early for everybody. In that case, I think it will be to the best interest for us, maybe to save some TA hours. Maybe I can use that maybe for grading, or maybe holding some alternative office hour, right? We're gonna monitor for that. Otherwise, letting the TA sitting idle over there on their Zoom for 1 hour without doing anything is kind of waste, right? We'll see. We'll monitor that for a couple of weeks to see what happened. And very important is about your lab number 1, right? So there is a tutorial video series I created just to walk you through about the very basics of the rodent tool, specifically how you can write formal specifications. And this particular tutorial, you should really make sure you understand that together with your review lecture for the math on week number 1 and week number 2, especially week number 2. For week number 2, we actually basically finish off the review about functions and also relations. And for functions, we also talk about some exercises about making modeling decision. You will see what I mean when you go to the slides. So whenever you will have to constantly make a modeling decision in this course, which means whenever you want to specify the formal models for your system, you want to decide, for example, whether the variable should be a partial function or should it be a total function. That's something I address in very much detail in your lecture number 2. So you want to make sure you study that carefully. Of course, ask me a question next week. So that'll be the tutorial, and then you will see some basics about rodent as well. The one thing I chose not to cover in your lab number 1 is about manual proofs. The manual proofs is going to be done in lab number 2, right? A little bit later, right? So I think one thing at a time. I don't want to throw too many things to you at one go. So just make sure you learn pretty well about the basics about rodent and get some intuition about what's being proved, at least for those examples which I explained in the tutorial. So there is a separate Q&A, like a Google Documents, for you to post questions related to lab number 1 tutorial. I'm gonna look through them, and I'll get prepared maybe for next week when we go over the questions. I can even go over some parts for lab 1 with you next week. But I would say attempt the exercises first before you actually hear the solution. That'll be the best, right? Right. That'll be something I'll really highly recommend. And your lecture week number 2 has been released. So far, it turns out for week number 1 and week number 2, we're only doing some math review just to make sure you have everything in front of you that you should really understand. We'll make sure we assess you about your math review concept in your written test number 1. I'll speak about it briefly in just a moment. And starting from week number 3, we will actually talk about case studies of seeing how you can understand the requirements for a real system and how you can formulate it into system models, and also refinement as well. So we're going to spend at least about 3 to 4 weeks for the very first case study in the most detail, and then we'll see other example as well in the later weeks. So that'll be the what I mentioned in the syllabus section, right? And for your written test number 1, let's now see. Let's have a look ahead, right? If you go back to the course page over here, 3342, and then if you go to semester calendar over here, let's see where we are. Okay, we are here, over here, right? And of course, this week and also next week, you're supposed to do lab 1, right? Follow the tutorial video. I think at that part, of course, you cannot work in group. You really want to watch the tutorial yourself. However, for the exercises I post in the lab, in the video itself, and also in the lab instruction manual, feel free to collaborate or to work with your fellow student, no problem. But if you cannot find anybody, that's okay. You can just work on that, them yourself. You're more than welcome to discuss the lab question together with me. I'll try to give you some guidance. And excuse me. It also hopefully lead you to the ultimate answer. The expected completion date for your lab 1 is about 28th. I'll try to I'll release the solution maybe 1 or 2 days beforehand. Again, attempt the problem first before you see the solution. And then your written test number 1 is going to be February 1st. Right? You still have some time to catch up. So I will give you the precise coverage either tomorrow or early on Monday, the coming Monday, to tell you exactly what you can expect on written test 1. It's going to be online. It's going to be on e-class and mostly multiple choices. And then I'll try to give you some example questions so you can get an idea about the format. Okay, but written test 1, I can tell you for sure right now, it is for sure going to cover week number 1 lecture, since we're going to talk about your question today, and also week number 2 lecture, since we're going to talk about it next week, and not about week number 3. So you don't need to worry about week number 3 lecture for your written test 1, and also for your lab number 1 as well. All the concept I cover in the Rodent tool may be covered in written test 1. All right. That's something I will specify precisely in the preparation guide. Again, I'm going to release the preparation guide either tomorrow or maybe early Monday, which will be 24th. So you got enough time to get yourself prepared. But as long as you follow through the lectures and also lab, you will be okay, right? Just ask questions whenever you need it, right? Okay. So that's about the announcement I want to mention. So hopefully everybody, if you're behind on studying a lecture, it's still not too late to catch up, right? You don't really want to leave all the hours of videos until a few days before the test. Even if you can finish watching them before the test, you may not be able to digest them. You can easily forget about them before the exam, right? All right, do you guys got any additional questions related to the general administrative issues of the course? Anybody? Please.
Professor, the
Yes.
test is going to be multiple choice, like short answer.
Yes, yes, correct. I will assess. Yes, I can tell you mostly multiple choice, maybe at least 70% or at least 80%, something like that. I will definitely give you some example questions, since it's going to be the very first test for everyone. I'll give you some example question there, and then there will be some written part possibly, in which case you might be asked to maybe write something, type in some answer box, and then submit the answer. That's that's possible. Yeah.
So we're gonna have like practice questions as well.
Yes, exactly.
Okay.
However, guys, that's something I always emphasize, but we'll see how that goes. I'll definitely give you some practice, right? For sure. That's not a problem for me. Okay. However, for the practice, you want to always remember that number 1 is mainly for you to know about the format for the test. Number 2, it does not really cover everything you're supposed to know, right? It's only example, not covering everything.
Okay.
All right. Very good. And I'm not gonna lie, usually when I actually give you the practice question, they tend to be more on the easier side. So you can definitely expect to see something maybe along the same line of thought, but maybe more challenging question for you to solve in the test. But of course, I'll make sure it's doable within 30 minutes for your time constraint, right? I just want to mention this to you so that you will still make sure you do the necessary hard work to go over the lectures, go over any anything that might need clarification, and also your lab tutorial. All right, that's something I want to make clear to every one of you. All right, guys, any more questions, please? All right, hearing none, let's now go over the question you have on the Google Doc. All right. Well, I think quite a few of them are just about clarification or something like you guys are very keen to know exactly what we're going to cover in the course. I'll give you some ideas, maybe not exactly concrete because it will be the most concrete when we actually get to there, right? Let's see. It's a valid concern over here. Since in your lab number 1, we actually will talk about requirements documents. If you go to your instructions PDF for your lab number 1, it's about the requirements, either E descriptions or R description. If you're not too sure what I meant, you will see once you get to the instruction and the video. So these two kinds of description for requirements documents are very necessary for you to know what exactly you're supposed to build for your system. So now your fellow student asked this question. For those kind of informal requirements like an E and R description for our context, right? Like an E description or R description. Will we ever need to create our own for this kind of an E or R description, or will there always be given to us to conform to? All right, it's a good question here. Number one is no. You wouldn't need to come up with the E and R description. Okay, you will always be given. You will always be given the requirements documents. Number one. However, number two, I want to give you a little bit more idea about what you will be expected to do in this course. Since that you will be given requirements documents, what will you then be required to do? What you will be asked to do will be to formalize the requirements into what in rodent terms either called context or machine, right? Maybe for those of you who hasn't get started, give you a little bit motivation to see how important it is for you to get started. And for the context, you have to declare constants, also axioms, and also theorems, right? These are all covered in the tutorial, okay? And also you need to know the distinction between either to make something axiom versus making them theorems. And also for the machine, and over here, we got to do variables. And also we're going to declare invariants. And also we're going to do events. And for every individual event, you have to think about what kind of parameters or inputs I need to put. Parameter and also the guards. And also the actions. So that's an overview about the ingredients of the model that you're supposed to come up with whenever you're asked to formalize the informal requirements. But we definitely do. You can see when I go over the tutorial video for Lab 1, whenever I try to do something maybe over here, I try to trace back to where that corresponds to the requirements document originally, right? That's something you want to pay attention to, okay? One thing for Harsha over here, making the requirement is what it is done in the 4th year requirements course, right? Yes, correct. So for those of you who, I'm pretty sure that's required, so you don't have an option, I'm afraid, okay? So for number 1 over here, if you want to learn about making requirement, like elicitate requirements or to formalize or to analyze requirements, EECS, 4312, I believe, if I remember correctly. I think that's what you guys have to take, maybe in the fall semester, right? And later on, maybe you will see me again, maybe next year around this time, maybe for the follow-up course to this one, which is the 4315, the safety critical system. In that case, you will also again be given the requirements documents, and then we just want to formulate them the same pattern, right? But that's for next year, right? It's a long time. to predict. All right, so that's about the first clarification, right? You will always be given a requirements document. All right, they'll be written in English, the natural language, and what you're supposed to know is about formalizing the requirements documents. And one thing is, whenever you want to formalize, there will be a lot of modeling decisions you have to make. Modeling decisions. And when you go over the lecture week number 2, you will see I gave you 2 detailed exercises to really to think through the modeling decision. I think those are the very common ones for you to go over, right? All right, that's about the first one. Do you guys got any follow-up question related to this? Anyone? Okay. Alrighty. Okay, you can always ask me later. Okay, let's move on to the next one. Okay, the next one over here. Okay, so here it's just look ahead to see what exactly the example that we're going to talk about, right? Because I mentioned maybe in your introduction, what like a lecture 1A in the last slide to say we're gonna draw the examples from different application domains, like a sequential, concurrent, distributed, and reactive system, right? Let me just mention them briefly. Okay, the first one that we're going to talk about will be reactive, like a sensors and actuators, right? That's what you guys did in 1021, right? You actually learned about sensors and actuator. And for those of you who maybe took 1021 with me back in winter 19, so it's a long time ago, but if you vaguely remember, whenever we did our lab, there were the software lab and also the hardware lab. And for the hardware lab, we tried to maybe program the feature board, for example, and then see how we can control the sensor and actuator, right? That's kind of the reactive system we're talking about. And the one we're going to talk about will be called bridge controller. And that is something you will get complete details about how to about the requirements documents, about the formalization, and about the various phases of refinement that we're going to talk about. Right? Let's not bother with the detail right now. You'll get there once we start the lecture. Okay, bridge controller will be the very first one we'll spend time with. Okay, and then tentatively we'll go for distributed as well, and we're going to talk about some file transfer protocol (FTP). Right? Just say how do things go from sender to the receiver. Okay, and also we'll talk about concurrent. And for this one, you can think about what you did in EECS 2031 back in your second year. I'm pretty sure you guys maybe got some opportunity to program multi-threaded program, right? Multi-threaded program. And for example, maybe one of the things you did will be the Fisher's mutual exclusion algorithm. Well, if the name actually rings the bell. Anyway, so in here, we're going to do something similar, but we're going to do some also concurrent algorithm. This will be a challenging one. Okay, we'll see how much we can cover. At least I can just cover the the basic part about the modeling. But I think for the proof, it's going to be quite challenging. I'll tell you exactly what I expect from you for the lecture, right? Harsher, bear with me. Let me finish the sequential, and then I'll call you for questions. Okay. All right, and also about sequential. So that'll be the last one. And over here, we're going to talk about one thing is about Hoare logic, about precondition, postcondition, and also how we can prove their correctness. That's something I will cover. And also, at least we'll cover like a sequential algorithm. At least one of them will be binary search. This might be very, you might think binary search is pretty trivial. Not necessarily. If I simply want you to write a fragment of Java code for me on a binary search, it is still tricky to see exactly when to make the recursive call and exactly what should be the boundary condition for the if conditional. So that's not exactly trivial as you might think. So that's something we'll study. Hopefully we can go over more than one example when we get there, right? So that's a very quick overview. Of course, we're going to see how things go dynamically. So if it really turns out you guys just need more details, maybe if you want me to go a little bit more slowly, I can definitely go more slowly. We'll see how that goes. Harsher, question.
Yeah, just to we're all on the same page. Unless there's a fourth year students in this class, we don't take 2031 anymore. We take 2032,
Oh,
which
okay.
so they don't have the multi-threading
Okay.
unit in
Oh,
that.
thank you.
It's about Bash, Basic C, and embedded.
Okay. Harsha, thank you for letting me know. Actually, I remember when we actually passed the proposal for 2032. Anyway, don't worry about, guys, don't worry. When I actually talk about this part of the lecture over here, I wouldn't assume any like a coding experience of multi-threaded program. Everything will be done in a more conceptual and formal way. So don't worry, I'll cover from scratch. So you wouldn't be disadvantaged in any way. But of course, if it turns out there might be even more background than I think that you really think you need, you can always let me know. I can maybe add some extra details. But don't worry too much if you didn't do any multi-threaded programming before. I actually wonder, maybe in your operating system course, 3221, right? So maybe in that course, you guys talk about multi-threaded program, I guess. Harsha, was that the case?
I haven't personally taken that yet, but
Oh,
there
okay.
are people
Okay.
they might answer it better.
Yeah, no problem. Okay, I can see some yes from the chat. Okay, very good. But anyway, so when I get to this part, don't worry, everything will be covered from scratch, right? You don't need to worry. That's a very quick summary about what I intend to really cover in this course. But I might be too ambitious. Maybe we need to slow down. We'll see how that goes. But at the end of the day, for your cumulative exam, I will only test you what I cover, right? So just enjoy learning in this course. All right, next one. All right, it's quite a long list of questions over here. In some way, I like it. I mean, you guys just want things to be clear, right? Again, this will still be just to clear things at a high level, so I wouldn't go into much detail. I'll answer one by one. All right. Your fellow students mainly referring to this model progression diagram. Okay, over here, right? Remember we said we're gonna start with. Oh, let me just show a little bit connection. For your lab number 1, we're doing the simple bank example. So the bank called bank 0 that we did is more like an M0 over here, the very simple one. Okay, and then eventually we could have adding gradually more and more details and get to something that'll be closer to the ultimate bank system that we want to do. Right, that's kind of like a connection. But for lab 1, we only do just a simple one, just to get you started. Let's now go over the question. Okay, what defines the most abstract model? I would say typically, just syntactically, right? You will see when we get to the bridge controller, there will just be only a small number of variables. Variables and also constants, together with their constraints. For example, the variable type may be just integer, or maybe the variable type should be a function or a relation, etc. But it will be a very, very small number of constant variables. So the state of your machine is very small, right? That's the abstract model, right? For the abstract model, we can already prove some simple property, but not necessarily everything. Okay. All right, the next one. Does it just satisfy one requirements? I would say not necessarily just one, but a very small number of requirements. Okay. So over here, A, only also small number of requirements, not necessarily everything, right? If you think about your requirements, actually got REQ, let's say R description, you got R1 up to R100. Maybe for your initial model, it only covers maybe R1 to R3, only 3. But what about the remaining 97? You can expect them to be covered gradually in the later refinement models. Okay. Okay, next one. What defines the most concrete model? I would say the most concrete model should be sufficiently close to the final code you would like to develop in any other language. But the model we have, it's a syntax, it's like a language independence, which means the code itself is not really following like a Java, Python, or C syntax, but it should be sufficiently close for the idea of implementing something concrete. Okay, so it should be something like a sufficiently close to some code for you to adapt to some language, right? Meaning that you got many variables, you got many constants, you got many constraints, and then up to that point, you got all the proof obligations automatically produced by row and discharge already, right? Okay, so over here, does it satisfy all the requirements? Of course, I presume over here when you say it, it's really referring to the most concrete model, ideally. Okay, I think to be more precise, I think that there will be certain example that we cover in this course or the case study. Sometimes I might also I might just attempt to cover how you may model, how you may specify the models itself. But for the proof, maybe I'll only selectively ask us or ask you to prove something. We don't necessarily have to prove everything because proving itself is really challenging task. So I will try to be reasonable, right? We wouldn't be trying to prove everything, but at least you get an idea. If you really want to prove it, that's how you would do it, right? So that's why I said ideally. You want to prove all the theorems that will actually encode the actual properties you want the system to satisfy. All right, next one. When do we stop adding refinements? I would say basically when you actually get to the level that's sufficiently close to the code. That's usually when you should stop. That's usually the case, right? If your ultimate goal is to really write some code that's actually correct by construction. So you want to have a series of refinements by adding more and more details until it's sufficiently close to the code. That's basically, right? All right, next one. How do we know what details to add in a subsequent refinements? Right, so I think this one over here, let me just, I think this kind of similar to, will you teach us the refinement process in detail? And also, because you mentioned that we will have to do this ourselves, this one, by the way, yes, you will definitely need to do some refinement sometimes. All right, and also, I'll try to answer them all together because they're relevant to each other. Okay, I think these three. I think the refinement itself is also a very creative process. I would say I will try to cover these, maybe sometimes give you some guidance about how this refinement can be thought about, maybe using case studies. I would say it's case by case study. I'll definitely teach you, at least for those examples. So if you run into maybe a different problem, but it might just sufficiently similar to those in the nature, right? All right, try to answer them all. And what does it really mean to prove a refinement? And will it be formal or informal? First of all, it will be formal, for sure. More specifically, let's say in Rodin, which I'll show to you, maybe in lab number 2. Let's say you got your bank 0 machine, and now you may decide to maybe introduce a refinement of that bank 0. In that case, once you introduce the refinement machine, like a machine number 2, there will be some proof obligation associated with the refinements, right? So formal, because each refinement triggers extra proof obligations. And I will speak about exactly what those proof obligations are formally, right? There will be some predicates for you to prove. And actually, in some way, they make sense, but I'll get there when we have to talk about it. And what does it really mean to prove a refinement? That means over here, what is, okay, so prove a refinement over here. So that means whatever proof obligation that's being generated by Rodin, of course, you got to study them as well to know exactly what the process is to generate them. That means to prove them. That's what we mean by proving a refinements. Okay. So for example, if you say given n0, I'm trying to make m1 a refinements. In that case, I'm basically trying to say any additional proof obligation generated by introducing m1, they should be discharged. And let me leave that proof obligation maybe unspecified right now. When we get there, I'll tell you the details. All right, for refinement. So far, I haven't talked too much about refinements. The only thing you should understand is for refinements, it simply means when you go from here to here, you have added some extra details, like extra constants, extra theorems, extra variables, or extra constraint. That's what you have done. However, you want to make sure somehow M1 is, I put quote, consistent with M0. But what do I really mean by consistent? That's something we have to specify precisely in the lecture. All right. The final question. how complex would the models be in this class? I would say we'll definitely see it when I get there in the lecture. Go to the draft of the textbook, which I gave you the link in the lecture site, right? Go there, log in, and see the PDF. Go to around the end of chapter number 2. You will see how complex the bridge controller can get into. So that might be the most complicated model you might see in this course, right? And also, it's not just about the individual model, it's also about the series of refinement model that we create. So that's collectively, they are the models for the same system, right? So I would say if you really want to look ahead, feel free to go to chapter number 2 about bridge controller. You will see, but we'll get there as well later. All right, guys, I hope that's somehow clarifying some stuff over here, but I think it's a valid question, but I think it's to best answer that when we get there. End of chapter 2, yes, that's what I meant. Yeah, end of chapter 2. Roughly about that. May not be the last page, but you will see what the model is like about refinements when you get to chapter number 2. Good. Right, any follow-up question to this? Anybody? Everybody's okay? All right, let me know. When you are marking our work, do you value correctness over creativity? Well, I think both are important, right? It's really hard to really say which one is more important. Correctness for sure is important. Otherwise, if you give me the wrong answer, of course I cannot give you any credits. On the other hand, creativity, from what I can see, we only teach a limited number of examples in the lecture, right? And those principles taught should be sufficiently enough for you to solve similar problems at a similar level of difficulty. Even for the more difficult problem, you also have some sufficient ground to really solve them. So I think creativity, yes, that's also important. Otherwise, if I simply don't repeat what I said in the lecture in the exam, in that case, how can you solve them, right? So I think creativity is also important. Both are important. It's hard to say which one is more important. Both are. All right. Any follow-up question to this? Anybody? Yeah, anything that's still unclear, you can always get in touch with me to see how I can clarify more. But I think that's as far as I can clarify, just for now, right? Okay, hearing none, seeing none, let's now go, let me go further. Right, so I think on the Google Doc, you want me to just go over these exercises. I gave you the solution already. Maybe just to make sure you understand the difference between proof and disprove, right? Right, let's now go over each one of them just to make sure you're okay with them, right? So whenever we say proof, over here is to really show that it is true. And of course, intuitively, when you say you want to disprove something, a predicate, in general, it's going to show that it's false. And depending on which quantification you're using, the proof or disprove process can be different, right? That's something I detailed in the slides. Okay, let's now take a look at the first one, right? If you look at that over here, first of all, you want to judge yourself whether or not this particular universal quantification is true or not, right? And this one over here, well, you guys have seen the lecture, so I don't need to give you time to think about, right? So let me just go directly to there. Here I'm saying that for all the x you can find that's integer and also between 1 and 10, every one of them is actually larger than 0. It does not seem right to me, because I can give you one counter example which sits in this particular range, but this is going to be false. For example, so I'm going to disprove it. In that case, maybe x is simply equal to, what about just, oh, actually, sorry, I saw the wrong range over here, sorry, beg your pardon. This one is actually okay, sorry, I was thinking that it's actually 0. Okay, sorry for the confusion. Let me take it back. Okay, this one here is actually okay, because if I consider this range over here, 1 all the way to 10, every one of them will be larger than 0, right? So in that case, it will just be true. All right, so that's true. And if you really want to justify informally, what you gotta say is, for the numbers 1, 2, 3, 4, 5, all the way to 10, they all are larger than 0, right? That's a very informal. So that's how I prove it, right? In order to prove universal quantification, you definitely have to make sure it's universally true. So you gotta somehow argue that for every number over here, all of them is strictly larger than 0, right? On the other hand, which I mistakenly thought that's what I was seeing. If I change this one over here to be 0, for example, right? In that way, I can disprove it, because in that way, I can simply give you a witness where x is simply equal to 0. And 0 larger than 0 is false, right? If I change the question that way. Okay, hopefully the first one is fine for everybody. Okay, and the second one is also about universal quantification. So if I look at that over here, right? This one, well, the same range from 1 to 10, but I'm saying every number is larger than 1. Now, this is not true, right? Because I can find a witness. So I'm going to disprove it by giving a witness. In that case, I can give you the witness of maybe just 1. Because now, if I do that over here, you can see I can instantiate x, every occurrence of x, by just 1. 1 is a member of integer, and 1 less than or equal to 1 less than or equal to 10 implies 1 larger than 1, right? Let's now evaluate this. This part here is true. This part over here is also true. And this part over here is actually false. So what we got is true and true is going to be true. And true implies false. As we learned in the lecture, true implies false will be false. Right? So overall it's false. So that's how you argue about why this will be a counterexample. All right, that's the second one. Hopefully that makes sense. And let's talk about the third one over here. And now we go to existential quantification, right? And proof or disprove, right? So here for existential, as long as one witness can be found that satisfies the property, in that case, it will be proved. Otherwise, it should be disproved. What about this guy over here? We still got the same range between 1 and 10, and we say that there's at least one number over there that's actually larger than 1, right? Well, there are many witnesses that we can find, right? We can find almost everybody except for 1. 1 cannot be a witness, right? So now if I want to prove it over here, the witnesses can be basically 2, can be 3, all the way to 10. All of them are acceptable. If you choose them, you're going to basically show, for example, let me say 3, okay? 3 is a member of integer, that's true. And also 1 less than or equal to 3, less than or equal to 10, that's also true. And also 3 larger than 1, right? You can see it's all true, right? So this one is fine. The only thing that cannot be the witness would be 1. 1 cannot be the witness. Right? So one possible question I can ask you during the exam is actually to see whether some value can be a valid witnesses or not, right? All these notes will be uploaded, yes. So you guys, don't worry too much about writing anything down. I will definitely make them available to you. I think focusing on what I'm trying to say here and ask question, that's more important. The conjunction, you mean the conjunction after, sorry, which one are you talking about? The conjunct after the closed brackets on the third and fourth expressions are supposed to be implication, right? This one is about universal. So that's why it's implication. And this one here is about existential. That's why it's a conjunction. Archer, is that what you're wondering about? Or am I misunderstanding you? No worries. Very good. Yeah, be careful over here. Basically, when we talk about universal, you got to talk about implication, right? When we talk about existential, you can talk about conjunction. All right. There's no bad question during the Q&A. No worries. Okay, Vanessa, please.
Hi.
Hi.
So, so if these were, let's say, like a test question or exam question or whatever, this kind of proof or disproof, like the way that you've written it, would be an acceptable answer.
Yes. Okay. Yeah.
Okay.
Let me try to
Okay.
let me try to move. I see what your concern might be. Depends on how I ask you, right? Let's say, for example, if this was the question on the test, proof or disprove. In that case, writing what I wrote over here will be completely acceptable. Yes, because I didn't ask you to really prove formally, right? However, there's another way I might ask you. I might simply give you this predicate over here. I might, if there's an easy one, I might just say, now tell me is it either true or false, right? In this case, you would say that's true. That's it. Or I would say, consider this particular existential quantification. Now for the following values of x, choose those that can prove it as witnesses. In that case, you will choose 2, 3, all the way to 10, but you cannot choose one, right? That will be another way I can ask you. There might be other ways, but at least these are the two ways. All right. Any more questions before we finish the final one, just for completeness for everybody? All right. Let me now talk about the final one. Again, it's existential, and we got a conjunction over here, right? We basically got the same range over here. That's from 1 to 10. So we got 10 values to consider, right? And then n x larger than 10. So we want to say this there exists at least one value. That means if you want to prove it, you want to find that value that's strictly larger than 10. Can we find such value? The answer is no, right? So now how do you disprove it? To disprove the existential quantification, you do not find witnesses. You want to somehow to say that in the entire range that we specify over here, for all the elements there, none of them can satisfy the property. That's why I cannot find a witness. That will be the idea, intuitively, right? Let me write it down. So here we want to disprove it. How I will write it, but you can take that as a reference if you want to write it this way. How I will write it will be, I can say disprove, I can say for all the integer that's in this particular range, 1, 2, all the way to 10. Each value is actually less than or equal to 10. Meaning that larger than 10, it will be false, right? Informally. That's how I disprove it, right? Basically, when I see your answer, I want to see that you definitely show the intent to really consider all the values in that particular range and say that each one of them is going to violate the property, so that you cannot simply find a single witness that will make you prove it. If you cannot prove it, then that means you disprove it, right? All right, that's about revisiting the 4 examples in your lecture slide for week 1. Do you guys got any follow-up to this?
Yeah, Professor, I have a question.
Yes.
It's just about the witness part. Because
Yes.
when I was doing the disprove of last one, there exists.
Yep.
Could you not say like x greater than 10 and then like flip it so it's like it's the same as saying x is less than or equal to 11? That's why it's not in the range. Would that not be the witness though? Like, I'm trying to think of it as like how we did it in stats. It's like greater than 10. It's kind of like x is 11 because 10 is not included.
Sure,
So
no problem.
would that number not be like a witness as well? Or would you just do the witnesses when you're trying to prove it?
Let me try to talk about this one specifically. Are you suggesting we modify this question slightly? You mean here, rather than larger than 10, what would you want? What would you want here?
No, like I'm saying that's right. Like to disprove it, I like what you said, like I completely agree. Because basically, like, because when you say x is greater than 10, 10 is not included in it, right? Which is
Right.
not included in the range. That
Right.
therefore it's false, correct?
Right, that's correct. That's correct. That's another way
then-
to put it. Yeah, that's another way to put it. Yeah.
Okay. And then what's the witness thing that you did in the question like before it? I'm then one is a witness, as in you use one to prove it.
Oh no.
So
Okay.
one.
Yeah, let me clarify. Okay. So whenever, okay, think about the very definition for existential quantification. So that means in certain range, you want to find at least one. That's why it's called exists. There exists at least one value that's in this particular range that would satisfy whatever property you specify. In this case, x larger than 1. So in order to really make this true, because the statement only claim that there's at least one, how can I convince you there's at least one? I show you that one, right?
Oh, okay.
That's how you think of it, right? So now in this case, if I want to prove it, so that means I can show you either 2, in which case 2 is definitely in this range over here. In that case, 2 is also larger than 1. So 2 can be a valid witness. So I don't need to give you more than one witnesses, just one. Because the very definition for this is only about there exists at least one.
Yes. Okay, I understand. Because like x is greater than 1 means like not 1 included. So another number that exists could be 2, 3, anything but 1, and that would be a witness.
That's correct.
That's
correct.
The proof.
That's correct.
Okay, I got it.
Very
Thank
good.
you.
Very good. Yeah, but guys, I think these kind of stuff are useful not just for this course, right? It's more about the logical thinking, right? About you definitely have to make some like either universal or existential statements all the time. In that case, how you can prove it or disprove it, you want to understand why we're doing that, right? Good. Arjun, go ahead.
For the third question, do we have to say that one cannot be the witness, like in purple where you've written?
Yep.
Is that like necessary to say?
Oh, it's not necessary. I just make a note. So if I only want you to prove or disprove, if I only want you to prove it, for example, the only thing I'm gonna say is witness can be 2, because let me say witness is 3, because this, when I substitute x just by this witness 3, is gonna be true when I do the substitution. So you definitely don't need to mention that one cannot be the witness. I just want to clarify to say not necessarily everything here can be a witness. Maybe some of them cannot be.
Okay, I see.
Good. All right. Awesome. All right, guys. Any more questions? You can feel free to think more deeply about this kind of stuff, and then feel free to ask me again, maybe next week. You're more than welcome to. Sana, go ahead.
I just had questions about the lab, if it's okay to ask.
Yeah, sure. You're more than welcome to.
Okay, so because I was watching the tutorial stuff that you posted.
Yep.
And you know your axiom versus theorem like section that you did,
yep.
where you had the context set, constants, axioms.
Yep.
I was confused a bit because we like concluded that C of 0 is not a theorem, right? And then you wrote C is a member of a positive number, and then we did and then there was a theorem part after, which is C is greater than 0.
Yeah. Yeah.
Aren't those two saying the same thing? But how come one would be an axiom and the other was a theorem?
I see what you mean.
How did you know like
which one should be axiom, which one should be a theorem, right? I see what you mean.
Yeah, because to me, like C is a member of a positive number, like 1, because it's at 1, right? So it would start at 1. Is the same thing as saying C is greater than 0.
Yeah.
But one of them you made a theorem and the other one is an axiom.
Very good question. Yeah, I'll try to answer that. Give me a moment. Okay, let me just get there, and then let me go back, close this. Okay, so I'm gonna say, oh, actually, sorry, not here. Bear with me. There we go. Okay. Okay, let me just bring everybody to speed just in case, so that you understand exactly what Sana was asking. Okay, when you went over your lab number 1, right? So this is the context over here. And I said that this over here to say C is a member of the so-called net1 set, right? So the net1 over here is basically net1. That's how you write it mathematically. It's basically going to be 1, 2, 3, all the way to plus infinity. Another way to think of it is basically you can say, use a set comprehension notation. It's going to be all such x, such that x is strictly larger than 0. That's another way to say that, right? Either way is okay to see the definition for n1 to net1. What I said in the tutorial was this is actually an axiom, whereas this is more like a derivable property from the axiom, right? And Sana was wondering why that should be the case. Why cannot be that both are axioms, or maybe it could be that this is an axiom, but this is a theorem. So Sana, that's what you're asking, right?
Yes, exactly.
Okay, very good, very good. I'm going to explain that, yes. All right, let's now talk about this over here. If you look at these two over here, so when we say C is a member of net1 over here, so this is a very special form, at least when we write formal specification, called a typing constraint. And I want you to recall what happened when I illustrated this particular video. When I first only introduced the constant C and then I say enter, and there was some compilation error in the rodent because it simply says C does not have a type. That's what they said. And I said in order to really give a type to C, we have to follow this particular syntax for membership. I want to say C is simply just a member of net1. So that's a typing constraint. And typing constraint is pretty much like whenever you are doing Java programming, right? Something like if you say I is actually, sorry, no, that's not how you write in Java. Let me just write properly. You can think about in Java, when you actually write integer I, formally it's really about I is a member of all the possible 2 to the 32 possible values you can draw from the integer type over here. That's really the correspondence over here. So this part here is really about typing constraint, which we simply assume. We will never make a typing constraint and theorem. That's not something we need to prove. Something you declare, really, you can think about. It's something that you declare. On the other hand, anything that's kind of this particular guy C larger than 0 over here, it is not really of the shape. Like so C larger than 0 over here. This is not really like a membership shape, of course. In that case, this will be something that we want to derive. It's a derivable, or it's to say provable from the typing constraint. That's what we are trying to do. And of course, you're right. These two things are basically equivalent to each other. I agree with you, but I think it's mainly about, since this is simply of the typing constraint, so that's why we simply say we want to actually just make it an axiom. On the other hand, for C larger than 0 over here, we just want to show you that you can make something just as a property, which can be derived from the typing constraint, even though in this case, it's trivial. It's pretty easy. That's why it can be proved automatically.
Okay. So
Yeah.
do we have do they go like hand in hand, like every time we were like to do an axiom, for example, write a theorem that replicates it, but not in the type that you declare it, but to prove that axiom?
I would say it depends on the application. I would say you definitely start with, maybe you definitely got the axiom about typing constraint, right? Think about what's going to happen over here, just in general. In general, what you need in a context, right? You got to declare the names of the constants. Okay, that's for sure. And also, you need to give the typing constraint for all the declared names. Typing constraints of the declared names. And of course, the one we just saw was simply one example. For example, we can so this one will be just C. For example, that'll be C is a member of net 1. There's another here, and then this part over here should always be axiom. They should never be theorems because that's something you don't really need to prove. Right. And then what can be what can be written over here about as a theorems? That would be many possibility. Right? Let me give you maybe some extra example. For example, I might say over here, let me just introduce another one. Let's say another one over here. Let's say maybe another one, for example, can I just introduce another, let's say C1 and C2. Okay, let's say C1 and also C2. And C2 over here, and also C1 is a net 1, and let's say C2 is just net, which means exclude the possibility of, sorry. So C2, the net over here includes the possibility of 0. All right. So possible theorem I can try to prove is, first of all, I can say definitely C1 strictly larger than 0. That's your lab 1. This one can definitely be checked. And also C2 larger than or equal to 0, that can also be checked. That's not a problem. Of course, alternatively, you can also say C2 larger than 0. That can also be checked. But if you try to say C2, oh, sorry, let me just write better over here. It can be checked. If you say C2 is always equal to 0, apparently you can see this one cannot be discharged. That one for sure, no, not necessarily. Let's go a little bit further to try to do something a little bit more interesting. Since now we have two constants over here, now I can try to do some property assuming that both are involved. For example, I can say C1 plus C2 always larger than 0. Would that be true?
I don't know.
Well, it's okay. Apparently I challenge you, which is good, right? Think about what's happening over here, right? C1 over here, we know that it's larger than or equal to 1. How about this? Let me just do it better. That one is definitely strictly larger than 0. We know very well. And also C2 over here is larger than or equal to 0, right? If I try to add these two numbers up, abstractly speaking, I give you something that's already larger than 0. Adding another thing, which will be larger than or equal to 0, would it guarantee the result will just be larger than 0?
Yeah.
Yeah, right? Go a little bit further. You can do a case analysis. Larger than or equal to 0 means it can either be larger than or it can be equal to, right? In the case of larger than, adding larger than 0 to something that's also larger than 0, for sure, that'll be larger than 0. Adding larger than 0 to something that's equal to 0 will still be larger than 0. In both cases, it will always be larger than 0. So that's what you will check.
Oh, okay.
Yeah, so just another example of property, right? Yeah.
Yeah, I understand now. Like, so every time you make it a typing constraint of like declaring your variables, you also need to have the theorem to like prove that.
To specify some
prove it.
properties. Some properties.
Yes.
Yeah.
Okay. Wait, but how come the C2 is greater than 0 is also a way to check it? Because for the natural numbers, it's 0 is included, right? But when you write C2 is greater than 0,
you're right. Yeah, absolutely.
Doesn't that not include 0?
Absolutely. C2 absolutely is larger than equal to 0. Yeah. Thank you. You're absolutely right.
No worries. Okay, yeah. I understand now. Like,
no
just
problem.
One thing of the lab that I didn't understand, because
That's
we wrote
okay.
the axiom, no proof needed, and then we just wrote a proof at the bottom. So I was just like, wait.
Right.
I was a little confused. Okay.
No problem. Let me see another one. Let me give you another one to think about.
Yeah.
How about C1 over here? Multiply C2 is always larger than 0. Very quickly. Can you prove or disapprove? Informally.
You could prove that.
No rush. Think about it. I'm pretty sure your fellow student want to know as well. Go back to the definition for these two constraints. C1 larger than 0, always. C2, there are two possibilities, either larger than 0 or 0, right? Now I'm saying that's always the case, including case 1 or case 2 for C2. When you multiply these two numbers together, it's always larger than 0. So now, should I be true or false? If you believe that's true, you can justify to me informally about the two cases. If you believe that's true, just give me a witness to show that it's false. That's okay. I don't want to put you to the corner. That's not my intention. Okay, let's talk. Think about it. That's okay. I think that's kind of the exercise you guys want to get creative, right? About. Let me tell you. Okay. Case number 1. C1 always larger than 0. There's no question. And also C2, we know that there are two possibilities. Let's say when C2 is actually also larger than 0. So that would mean C1 multiplied by C2 larger than 0. This one's easy, right?
Yeah.
What about number 2? C1 larger than 0 as always, right? It's a net 1 always. And C2 equal to 0. Wouldn't that just be 0?
Yeah.
Since we have one possibility where the two multiplication can be 0, so when you say they're always larger than 0, that's simply not true. Does it make sense to you? So this will be the counter example. Okay, guys, think about it. That's okay. So this will be no, and this will be the counter example.
Oh, because it could either be greater than 0 or it's equal to 0. And if it's equal to 0, you can't get a number that's greater than that, which
exactly
disproves.
Yeah. Basically, what you're saying is, you're saying that for every possible combination of values for C1 and C2, they're always going to be, their multiplication will always be larger than 0. That's what you're claiming. And I'm saying that is false because I can find at least one combination of C1 and C2 that will falsify this relation. In which case, you have to do some case analysis over here because you know that for C1, well, in this case, we don't need to distinguish between how large C1 is. At least I know it's larger than 0. But for C2, since it's in natural number, so it can either be larger than 0 or it could be equal to 0. In the first case, you're only just multiplying positive to positive. The result, of course, is positive. That's not a problem. This will satisfy its claim. But there might be other constraint, other combination, which will falsify the claim. So if you got C2 equal to 0, in that case, 0 multiplied by anything will just be 0. So this will be the counter example to show that this cannot be true.
Yeah. Okay, I got that.
Good, very good. So guys, don't be too surprised. I'm glad Sana actually asked for everybody's benefits. Don't be too surprised if I give you something like this, similar along the line, maybe in the test. Okay, so just get prepared. Very good. All right, so don't worry, you guys can think about it. If you want to come up with more example and challenge me, I'll definitely answer that. Right? Maybe excuse me, later. I can see one hand raised. No.
Yeah, I just had a
go ahead.
Quick question.
Yeah.
So for our definition of natural numbers, you said that we're actually including 0.
That's correct.
Would you like? Are you like? Would you like specify that on test? Because I think like the usual definition is like I thought it was like 1, 2, 3, 4, or I guess.
I think I wouldn't specify that. How about this? You can see here. When I say n only, it's going to be a natural number including 0. But when I say n1, this one make it very explicit that it's going to start from 1.
Oh, okay, I see.
Yeah, but of course, I see what you mean. Maybe in the question itself, I might just mention only this. In that case, you might think it's actually larger than or equal to 1. That might be what you're thinking. So I would say, yeah, make sure you clarify that. It's something I also make sure I said that in lecture number 1. So yeah.
Okay, thanks.
No problem. Harsha, please.
We're doing 0 included because the book did that, right? So all the examples.
I think the book, yeah. I think to be honest with you, I'm not too sure. Maybe you guys can tell me. In your earlier 1090, for example, did your professor say that natural number should include 0? Well, not include 0. You guys can tell me.
I think it was controversial. I remember in first year,
Yeah.
George Terlakis kind of said that it's controversial in math and it varies
Okay.
from book to book and
Right,
scholar
right.
to scholar.
Yeah, that's what my impression too. So I would say, guys, please, for this course, I will never change the definition, right? Whenever I talk about n, always include 0. When I talk about n1, it will be n basically union with just the value of 1. That's how you can think of it. All right? Good. All right. Guys, I think we are getting to the end. But there's one more thing I want to mention that's also on the Google Doc. I want to clarify, right? Let me delete this over here. Okay, and now I want to make some concluding remark for everybody before next week. I think there was an embarrassing typo made by me. I want to point it out. Thanks to whoever pointed out to me on the Google Doc. When I talk about the conversion between the two logical quantification, in the rule itself, it was actually correct. I didn't make any mistake. However, when I gave the example, maybe I just wrote it wrong. Okay, so this part over here about conjunction, this over here should be disjunction. However, if you just go back to your lecture site and re-download the written notes, I have updated already, so it's not a typo anymore. Right? I want to point it out in case you're still keeping the old version or you're wondering about why. All right, that's about everything I could see from the Google Doc. Do you guys got any more questions before I just mention some tips before I see you in a week? All right, do you guys got any more questions for me? We are running out of time anyway, so I'll make it quick. Any questions, guys? But yeah, so if you do know your fellow students actually somehow didn't know how useful the Q&A is, you can tell them, encourage to attend and ask questions. I try my best to give you guys some more clarification. Oh, somebody added more to. Is it possible for you to look? Yeah, sure. It wouldn't take long, I hope. There's some new question. Yeah, guys, usually try to post all your question maybe before Wednesday. Well, before Thursday, that'll be the best. So when I look at that, I wouldn't miss. So let me just go. Site. You can tell me exactly where to go. Let me go there first. Can you tell me where to go? Where? Oh, sorry, that's not the one. That's for second week. 1B D4, okay? Oh, D4, thank you. Let's go to D4 over there. Okay, let's take a look. Isn't the R is an element of our series paradox? SDR over here. Oh, I see what you mean. Over here. Yeah, you're just saying that. Yeah, I see what you mean. Good points. Yeah, I didn't think that much when I was writing it. Yeah, you're right. Because there's a name clashes over there, right? Because here we're talking about relation R over here, but we're using R again. Yeah. Okay. I'll fix it. Thank you. I'll fix it.
Oh, Russell's paradox thing, right?
Yeah, paradox. Yeah, you can say, yeah, or if you do this in programming, you want to define something in terms of itself, you got Stack Overflow, right? No problem.
Yeah, like if we're defining relations as sets,
yeah,
then a set can't be a member of itself, right?
That's correct.
So
thank you. Absolutely. Thank you for pointing it out. I definitely didn't mean to have a paradox for you. Yeah. All right. Wow, you guys are so knowledgeable. Good. Jackie's comments, and then I would say, okay, thanks, George. All right, we'll fix it. Right, I'll fix it, and then I'll tell you when you can re-download. Right. Okay, awesome. All right, guys. Anything else? Okay, if I may, let me give you about 1 minute, very quick look ahead about what you really should try to do before next week. I would say for this week, you want to study lecture number 2, the second part of the math review, very carefully. especially, let me go to the slides. You will see two very important exercises over there. And those kind of rationale were actually applied in the lab 1 example I did, right? You will see what I mean when you get there. And you will see here, I got over here. Let me just go there first. This will be one. It's a very long, detailed slide over here, but definitely follow the video. I definitely went point by point about making modeling decision. That's what I said in the very beginning about earlier today. You will be given some informal requirements or informal description, and then you have to make a decision about how to formalize it, formalize the situation into mathematical variables. And you definitely got options here. Either you want to formalize it as a relation, or you want to formalize it as the total function, or you want to formalize it as a partial function. You want to go for the most accurate way that's valid, right? That's something you can just follow through the story I told in the lecture video. And the very final one over there is also very important. Oh, sorry, not second last one over here. So this one here is another modeling decision you will actually have to face very often. So here I just trying to give you an example. This is what you learn from the Java course about how to declare a sequence of string called A, like an array. How do we formalize it, right? So I talk about different possibility over here, and you want to see exactly what the consequence would be for each one of them. That's kind of the stuff you will be expected to do also very often in this course. You want to turn informal things into formal things. So there will be no multiple interpretations for the formal things. All right. I see some hand raised. Anybody? I see thumbs up.
Yeah.
Yeah, go ahead, please.
I asked in the chat, I'm not sure if you read it. I just a quick question. So, you know, for when you're defining like domain in the lecture, like it was in like a relation and with a relation with a set of ordered pairs, it was like the first element in the
first element in the pair. Yeah.
I was wondering if like if we had more than ordered pairs, like if it was triplets, like what would the domain be there, or is it possible to have a domain there?
I see what you mean. I think what I really meant to say there, I believe that's the case. Yeah, I see what you mean. You're saying the domain value, the first element itself may just be a pair itself, right? That's what you're saying.
The first. Or like if it was triplets, right? What would the domain be there? Because like would it be like the first element and second element? Or
well, I think it depends on how you define. Let me give you. Let me be precise. Let me go there first. It depends on how you specify the SNT over here. So you think about the very definition for SNT over here, right? If I say S itself is only a set of, let's say, single elements like A, B, C, D, in that case, domain will just be A, B, C, D, a single element. But if I say S over here is simply just a set of pairs, in that case, every domain value will be a pair.
Yeah, that makes sense.
Yeah, it's a good question here. You know, I like it. Let me make it precise, and then we're done. Okay, for everybody. Okay. If I have, let me give you the contrast. If I got AB over here, for example, let's say F is simply a member of all the possible relation between AB and also 1, 2. Okay, let's say. And I definitely can say F, that's just one example. It could be maybe first element A, and then second element maybe 1, and also maybe B, and also 1. But it's not injective, but that's okay. Okay, let's now try to contrast this with something slightly different, which I didn't mention. I didn't really mention in the lecture, but according to definition, it's also possible. Let's say F is let me say G, so you don't get confused. G is actually a member of. Okay, let me put it here. Let's say A1 and also B2, right? Just 2. A relation between. For this part, let me just say C and let me just say X and Y. Okay, that's possible because you can see this part here just S, the first set. It's just that every member in the set is just an ordered pair. All right. So now, if I try to say here, I can say one example for G would be over here. Overall, it's going to be ordered pair. So ordered pair over here, and then I can say A1, and then I can say Y. And also I can get maybe B2. And then I can get X. That's just one example. So you can see A1, A1, B2, B2. These are the domain values. So if you try to calculate the domain of G, in this case, it's going to be A1 and also B2. Make sense to you?
Yeah, I just had one more quick question. When you say member of, like, I'm thinking of one thing. Should that be maybe subset?
Like, no, member of. I really meant member of. So if you look at this particular part over here, right, we said this as synonym. It's a synonym to the power set of the cross product between these two, right? So that means in that particular power set, every member in that power set is a set of ordered pairs. And I'm saying that F is simply one of such set of ordered pairs.
Yeah, that makes sense. Yeah.
Good. Awesome. Good. Yeah. But guys, I think your fellow student asked a very good question here. You want to make sure this is also makes sense to you and make sure you understand the basic definition very well. Again, this will be part of the creativity I want you to have, right? Patrick, quick.
Yeah, so in a similar way, maybe we could also have something that maps a single value to an ordered pair, right?
Yes, absolutely.
You could have absolutely. Like for example, like a function, a 3D function, right? A function in 3 dimensions. You can have an X value mapped to a Y, Z, right?
Yes, absolutely.
I guess my question is there's no real restriction on what the entries of an ordered pair in a relation or function can be, but the idea is that we can represent any, I guess, input-output value as an ordered pair. So you can have an ordered pair of ordered pair of ordered pair of ordered pair if you really wanted to.
That's exactly correct. That's more on the like how you know. That's why people say relation is the most general form you can put to model real-world entities, and that's really the theoretical foundation for relational databases. And maybe I mentioned briefly for those of you who actually will study or is studying 3342, the database courses. I'm pretty sure you learned about something called relational algebra. So that's really where people talk about like how you can use relations to really formalize SQL tables. So my point is, you're right. So here we only say S and T over here between the two between this relation here is only just individually set, but set what each member, how complicated each member is, well, what their structure is completely arbitrary. It's completely up to you, up to what you need for your application. Good. All right, guys. I hope it was useful today, and I think we're really running out of time. Thank you for staying. If you guys have no further question, I would say please study everything. Reach out to me. It doesn't mean this is the only chance you can ask me question. Reach out to me, office hour, appointments, whatever. All right, and otherwise I'll see you next week. Make sure you finish lab 1, right? I'm gonna talk about some highlights for lab 1 next week as well. All right, guys, you take care, and then I'll see you later. Reach out to me whenever you got doubts.
Thank you, Professor. Bye.
You're very welcome. Bye-bye.